So, okay, shall we go ahead? Okay, see here. At least can you able to understand this SR flip flop, please?
Sure.
So give me the response. If the input is 0 and 1, what is the output? Qn plus 1 is equal to Qn. Please respond those who are there in online. So when you give the input as 0 0, the I mean decimal 0 and 1, the output is Qn plus 1 is equal to
Zero,
Qn.
zero and one.
Yeah, which is nothing but Qn plus 1 is equal to Qn. And when if you give the input as 2 and 3, the output is only reset value. When you give 4 and 5 as the decimal input, the output value is only set value. And when you give the decimal value 6 and 7, you are going to get the value is undetermined. I think up to this table it's very clear.
Yes,
So
sir.
slowly we'll enter into K map. So where this K map is completely your department, we'll enter it and we'll slowly try to handle. So now the problem with this SR flip flop is, so this state is there, no. So this state giving both same inputs is meaningless. Giving both same inputs as once is also meaningless. Therefore, these types of inputs are not useful. So therefore, we are going to design an D flip flop where the 0 0 as well as 1 1 inputs can be neglected. I mean, these inputs are practically not useful. Therefore, we can neglect these two inputs. Okay, so uh, now let's try to see in 0 0 what happens is qn plus 1 is equal to qn, where this kind of output is not useful. If both inputs are 1, then I'm going to get the outputs as undetermined. This is also not useful. Therefore an delay flip flop is designed. D means which is called as delay flip flop. So this is flip flop is also an, how many memory bits it can store? Flip flop is an 1 bit memory storage. So like this, some thousands of flip flops will be there in your computer, which is called 1 bit memory storage unit. So this delay flip flop is going to delay with one clock cycle. That's why it is called, they get delayed, or this flip flop get delayed by one clock cycle. Then how it works, let us try to see here. So in this D flip flop, we are going to modify 0 0 value as well as 1 1. Therefore the modified SR flip flop, the modified SR flip flop with one cycle delay is called as a D flip flop. D flip flop or JK flip flop or SR flip flop is basically an 1 bit memory storage element. It can store either one value or zero value. Now, what kind of modification I have to do is, I have to remove this 0 0. I mean, I have to remove these decimals 0 1 as well as 0 0. I mean, these conditions having both inputs are same, this condition is actually not required. In practical application, this input condition is not required. Therefore, we need to remove. Okay, so therefore now again we are drawing an SR flip flop. Okay, so let us try to draw a small block diagram of a SR flip flop. So what are the inputs of an SR flip flop? One is S, another one is R, and output of a flip flop is how much? Q, and another one is Q bar. So the output of flip flop is Q, and next one is Q bar. So I don't want both the inputs to be 0, and I don't want both the inputs also to be 1. So therefore I'm going to define an input D, and D is directly connected to the input. Okay, so D is directly connected to the yes, but here I'm going to use an AND operator. Okay, or you can take here I'm going to use one NAND operator, and I'm going to connect it to R. Okay, so like this I'm going to provide a delay of one clock pulse. So this providing an 1 unit clock pulse is very important where we can neglect. So this may be, so if you have you can consider this as an inverter, or you can consider this as an NAND gate. So basically this is an inverter. If you are constructing this SR flip-flop with NAND gate, then you can take this also with one more NAND gate also. That depends upon how you design this SR flip-flop. So this is how we are going to get the input. Now let us try to design. So this is called the logic diagram of an D flip-flop. Very simple. We'll be having a SR flip-flop. To this SR flip-flop, we are connecting D directly to the S, but we are complementing the D value and we are connecting to the R input, and the output remain same. So now let's try to draw the diagram of an SR flip-flop. So here how many inputs we are going to have is nothing but a first one is D is only one input, and the another input is nothing but one more input we are going to have is a Qn. So and here to make it to work, we are going to connect an clock pulse. Okay, so here we are going to, this point is called, we are going to connect an clock pulse. So this is 1 0, and again 1 0. This is called clock pulse. We will use clock pulse when we are using an flip flop. If you're using a flip flop, if the flip flop has to work, then we want to use one clock pulse. So we are going to connect an clock pulse. This is how the diagram of an clock pulse will be. Now first input is D, and another input is nothing but Qn. Okay, so therefore we are going to get, so Q N and D are called as inputs, and you are going to get an output which is nothing but Q N plus 1. So here how many inputs are there? So two inputs are there. How many rules we can write down? 2 square. 2 square is equal to how many possibilities we are going to have? 4 possibilities. So therefore we are going to write down the decimal numbers for these possibilities. Okay. So how many, 4 probabilities how to write down in decimal number? Anyone? 0, 1, 2, 3. When you write down this in BCD form, this is 2 to the power 0 is how much? 1. 2 to the power 1 is how much? 2. Now write down this in binary form. How to write down? 0, 0. Next one, 0, 1. Next one, 1, 0. Next, 1, 1. So what are the inputs to this D flip flop is, one is a D and another one is the same complemented one, which is nothing but a Q1. We need to find out the Qn value. Okay, so now see here. So this we will do the derivation. The Qn plus 1 is called as the next state of the flip flop, and Qn is called the present state or the present input of the flip flop. This is called present input, or this is called the present state. Therefore the output of this one we are going to get, so this we will do the derivation. So Qn plus 1 is the next state, or this next state is also called as the output. We are going to get it as D. So what is Qn plus 1 value is D. What is the value of D here? 0. So what is Qn plus value? 0. What is the value of Qn plus 1 in this row? This is also same as D. This is also 0. What is the next element in this stage? Whatever the D is there, the same will be there. Whatever the D is there, same will be there. So successfully we have been constructed an flip-flop input with D and one more input with Qn, and Qn plus 1 is called next state, where this is called the output. And all this flip-flop will work only when we give an positive triggered. So this is called gate pulse. Already I told this is 1 and 0, and here you are going to have gate pulse, and this is called a delayed gate pulse. Okay, so we have to provide this gate pulse of one cycle. So where this is called as a delayed flip flop. So this delayed flip flop, we are going to provide a delay of one clock period or one clock period. So this complete cycle we should make the output as completely 1 and then 0. So like this, one clock cycle will be 1 and another clock cycle will be 0. Therefore, this kind of output is required in delay flip-flop. So now we need to derive this expression, and this diagram is called timing diagram. All your machines, computers will work on the timing diagram. You have to learn this timing diagram. No worry, slowly we will understand. Okay. Hope at least up to here is it clear? Please respond.
Yes, sir.
Shall I repeat again? So
Yes, sir.
actually we are having an SR flip flop. In this SR flip flop, 0 0 input, 1 1 input is not needed. Where this is not needed for an flip flop to work. So we will eliminate these two, which is called a modified SR flip flop is called as an D flip flop. D flip flop means it is an type of a flip flop where the name D means delay. How much delay means it is delayed by one cycle. So this is called once, this is called positive cycle or this is called negative cycle, or you can take this is logic 1 and this is called logic 0. Complete your flip flop should be delayed with a time period of 1. Then these kind of flip flops are called D flip flops. Now take your SR flip flop, and to this SR flip flop, to here you can see here, uh, 0 0 means not required, 1 1 is also not required. When we can eliminate this one is, so I want only these values. Okay, so these values only I want. How I can have these values is, one should be 0 and other should be 1. Therefore I'm going to perform a complement. So I'm taking the input is D, and D directly I'm connecting to yes, and another one I have to connect with an inverter, and I'm going to connect to R. Therefore, the outputs are Qn. This is called Qn and Qn bar. These are the what we call it as present state, and the output we may get Qn plus 1 and Qn plus 1 bar we are going to get. Okay, the same I have been drawn. So how many inputs are there, everyone? How many inputs are there here? Two inputs are there. So one is D and another one is present input. With the two inputs, how many possibilities we may get? 0, 1, 2, 3, 4 possibilities we may get, which is nothing but 2 square is equal to 4 possibilities. Then write down the decimal equivalent binary number: 0 0 0 1 1 0 1 1. Then you are going to get an output Qn plus 1 is equal to D. How we are going to get Qn plus 1 value is equal to the D value? So in the place of Qn plus 1, I'm writing the D values as 0 0 1 1. So this is how we are going to say. So that's why now let us try to develop. So the this is called the truth table of an. So this is called the truth table of D flip flop. So this is the truth table of D flip flop. But I want the excitation table. Excitation means the output. Okay, so the output table, the excitation table of D flip flop. How to get the excitation table of an D flip flop is with the help of an map, which is called as K map. K map means this is one type of analysis, so which is called kernel map. Okay, how to do this kernel map is, so here how many inputs are there? D and Qn. So D we will take, we'll draw one line, and D we will take at one side, and one more input what we have is Qn. So this Qn we are going to draw this side. And how many inputs are there? Four we have to get. So how many, how to draw is, so first we will draw one 0 here, and we will draw the 1 here, and here we'll take a Qn is equal to 0 here, and we'll take the 1. So what is the combination? 0 0 0 1. Okay, 0 0 means 0, 0 1 means 1. So 1 0 means 2, 1 1 means 3. So the same what we have been got here, we are going to construct here. Okay, now let us analyze the D flip flop. So here when you take it, so please identify. So how to write down this 0 0? Here you are going to have 0 0 means draw one horizontal line, draw one vertical line. 0 0 means this is 0 0. 0 1 means this is 0 1. So this is 1 0. This is
10.
1 1.
1
So
1.
we have been converted that truth table into an graph, where this graph is called k map or k graph. This k map is used to find the output equation. How to do is, so now one is there. How to write what is the variable we are having here? D. So one, how to write down in the form of means, one can be written as D. Then how to write down 0? Just to put an bar on this one, which is called D bar. Are you able to get?
Yes,
The
sir.
same you have to represent in a graph. This technique is called K-map. How to write down the technique is, how many possibilities are there? Four possibilities you have to get. You know how to get four possibilities means, write down 0 here, write down 1 here. Write down 0 here, write down 1 here. So 0 0 0, 0 1 1, 1 0 2, 1 1 3. So here you're going to have 0 1 2 3. So four combinations we had got. So how to write down 1 means, just write down D here. How to write down 0? Complement. Complement means put an bar on this. Okay. So the first one is called D, another one is called D bar. And how to write down what is the variable here? Everyone should give the response. What is the variable here? Qn. So 1 I can write down it as Qn. Then how to write down this 0? Complement of Qn. So where I can write down Qn bar. Are you able to understand? 1 we
Yes,
have to
sir.
write down it as D, 0 we have to write down it as D bar. 1 you have to write down it as Qn, and 0 we can write down it as Qn bar. So after plotting it, you identify what are the variables. You just see here 0 0. So 0 0 means D is 0 and Qn is also 0. 0 0 means what is the output you are going to have. So from this graph, we are going to plot the output equation Qn plus 1. So 0 0, what is output? See here, 0 0, what is output? 0. So
0.
write down 0 here. Next, for 0 1 combination, what is output? 0. Write down here.
0.
Next, for 1 0 combination, 1 0 combination, what is output? 1 here. Write
1.
down the 1 here.
1.
Next, for 1 1 combination, what is output? 1 here. So
1.
now we
1.
had got the elements. What are the elements are there here? We had got the same elements 0 0 1 1. Now this is called K mapper. Now if how if you should have at least one two ones or four ones like that will be there, we have to make it group. So here I can make how many ones are there? Two ones are there. So just make an circle on this 1 1. Okay, when you make a circle on this 1 1, this will give the value of Qn plus 1. So 1 1 are there in which column? So this is row 1, this is row 2. What is the value of this element? 1 is there. How to write down this one? So what is the name of this row? D. So just write down D. Okay, and that's all. When you come to the column, in column one is Qn and another one is complement. We cannot write down. Why? Because both are complement. If you write down both, it will get cancelled. Therefore, you are going to get 0. So D plus 0 is nothing but D only. So therefore, what is the characteristic equation you are going to get is Qn plus 1 is equal to D. So the same I had written here. Qn plus 1 value is equal to D is the output equation. Okay. So this is how is the K map clear, or shall I need to explain again? Hello students. Is the
Clear,
K
sir.
map clear? Shall I explain again?
Clear, sir.
Okay, just very simple. Whatever the values of Qn plus 1 are there, just you write down. 0 0 means what is the value you have to write? 0 here. 0 1 means what you
0.
have to write? 0. So 1 0 means what you have to write down? 1. 1 1 means you have to
1.
write down 1. So
1.
whatever the values of Qn plus 1 there will be coming to our table. So in this table, you should round two ones, you should round four ones wherever there. Okay. So what is the convenient way of rounding is this way I'm going to round. So this is which row? Second row. What is the element in the second row? D. Just write down the D
D.
value. But we cannot write down the column value. Why? Because so when you write down the column value, one is Qn, another one is how much? Qn bar. Q into Qn bar will become as 0. So
0.
therefore, Qn plus 1 is called as the output equation, or this output equation is called as the characteristic equation of an which flip flop? D flip flop.
D flip
Okay,
flop.
flip flop means just is like memory storage. How you have a RAM in your computer, Basically, a computer is has a flip flop. From flip flop, group of flip flops is called RAM. Group of RAMs will do your work. Okay, so that's what the basic energy storage device. Now we want to draw the diagram for this one. Okay, so now how to draw? So this table is called. What is the name of this table? This table is called excitation table. So this is called excitation table of an D flip flop using which map? K map. K is nothing but
So,
what is the name of this map means kernel map. Okay, this is one of the shortcut method to find the output. Okay, now coming to the how this D flip flop will work. Okay, so in order to work for the D flip flop, first we require an gate pulse. So this is nothing but our gate pulse. Okay, so here we are having gate pulse. So this is called as a gate pulse, or we'll call it as a clock pulse. What is the level of triggering here? 1. And if you give this value only, your flip-flop will work. If you don't give this signal to the flip-flop, it will not work. So therefore, here the level given to the flip-flop is 1, and after 1 second, it is decreased to 0.
0,
So 1 to 0, this is called positive level, and this is called negative level. When
negative
both are combined, then it is called actually one period.
1
And what kind of period it is called? This is called clock signals. Therefore, this is called as a clock period. So one period is the clock period. So when you draw it, the output. So this is d value you have to draw. If you draw the d value also, this will be like this only. Okay, so the d value is also the same fashion you are going to have. But if you are drawing this qn plus 1, so this also will be same. Okay, sorry, this you try to draw extend for one more cycle. So this will be delayed like this, it will come and it will goes to 0. Okay, so it is delayed by one clock period. Okay, so like this it is going to get. So qn plus 1, when you draw the waveform also, this also, I mean, what is the equation of qn plus 1? Qn plus 1, just it will follow the value of d. So how the d is there? D is having 1, and later on it is coming to 0, and like this it follows. So this is 1, this is 0, this is also 1, this is 0. I can make a comment qn plus 1 just to follow the output. So this is one clock, this clock is getting delayed. Okay, so therefore this flip flop is called as which flip flop? What is the name of this flip flop? Delay flip flop. It is delayed.
delay.
So what is the advantage of delay flip-flop means it is eliminating the inputs of 0 0, and it is eliminating the inputs of 1 1. So where these inputs are not practically useful at anywhere, therefore these inputs can be eliminated. So this can be eliminated. This is called a D flip-flop. D flip-flop means delay flip-flop. D flip-flop is constructed using a modified SR flip-flop. Okay, so this red colored one is there. No, if you do only for these two, then this is called an D flip-flop. I think now it's clear for you, right? Yes or no? Is it clear or not?
Yes, sir.
Huh? So shall I stop? We'll write the notes. Shall I stop or shall I proceed? Hello.
Will write the notes, sir.
Yeah, I will give for 1 minute. Just write the notes. So just listening is no useful. You just listen, and after the class you practice. You should get the output qn plus 1 is equal to d. That's what you should learn. Now we'll go with the next flip flop. Take some time and just write down. I think screen is visible clearly, right?
Yes, sir.
Go ahead. 1 second. right now. So all your computer subjects will be same. If you understand this digital logic design, then only you can study your subject easily. Complete your electronics, I mean, complete your computer science, you will study about this clock pulses only. So that's why you should understand what is positive, what is negative. If you are completed, please give me, say yes. I will proceed with the JK flip flop.
Yes, sir.
Mm. Okay, how many are there in online? You are distracting your sleep and you are coming to class. Good. Still 19 are there. Good. So we have only one concept is left, counters. If time permits, we'll take in 2 hours in class. Otherwise, I'll put an exam what has been covered in these online classes. If it is completed, let me know. Manasvi, are you there in line?
Yes, sir.
Are you watching the video?
Yes, sir.
Okay. Nishita, are you there in?
Sir.
Are you listening?
Yes, sir.
Okay. So please don't keep in what is that ideal mode. Keep the phone and just move away. Just be focused. I'm identifying whether you are focused listening or not. Monica, not there. Nani, okay, Nani. Okay, good. You are focused. Okay, is it okay? We will proceed. Give the response. Ayusha.
Okay, proceed.
Okay, good, super. So now let us try to see the output. What is an SR flip flop? Given an overall view, SR flip flop is if both are 0 0, output is how much?
Zero.
So if inputs are 0 0, output is Qn plus 1 is equal to Qn. If the inputs are 2 and 3, what is the output? Reset. If the input are 4 and
Zero.
5, output is how much? Set.
One.
If it is 6 and 7, output is what? Indeterminate.
Invalid.
So this top one and bottom one we eliminated, where we are going to call it as modified SR flip flop is called D flip flop. That's what we have been designed. And now we want to go for the next flip flop, which is called JK flip flop. Okay. So very simple. This is JK flip flop. What is a flip flop basically? Flip flop is an
Lo-
one bit.
One bit memory storage.
Very good, super. It is an one bit memory storage. And means what it store? Either it can store 0 or it can store
Zero.
1.
One.
From where it will store? It stores in the computer RAM. If you give any operation to your computer, it need to store that memory. Where it will store is with the help of flip flop. I mean group of flip flops. Then we can call it as a RAM. So in your phone also you have 8 GB RAM, 16 GB RAM, 36, 32 GB RAM. All this is nothing but group of flip flops. They will just store either 0 or 1. Okay, so that is why it is called JK flip flop. Now what is the importance of JK flip flop is, so JK flip flop is also we can call it as, I mean if the flip flop has to work, what we require, one more input is clock pulse. What is clock pulse? So clock pulse means this will be a signal like this. Okay, it starts with one magnitude and it goes to zero, and again it comes to one and it goes to zero. If this signal is given to your flip flop only, it will work. That's how we have to understand. Okay, flip flop will work only when we give this clock pulse to them. So now, how to construct an JK flip flop is, JK flip flop is also called with one more name, where it is called a modified SR flip flop, where it is called modified SR flip flop. Sir, how this SR flip-flop is modified is very important now. Okay, now let us try to see the modification, what you have to do to construct an JK flip-flop from SR flip-flop. Okay, so don't ask me, sir, how to remember this table. If you are talented, yesterday morning I had yesterday explained you the logic. You can use that logic, or if you want to prepare for exam, just you keep this table in your brain, or write down this table on a white paper. The I mean, what is that? Truth table of SR flip flop, truth table of D, truth table of JK, truth table of T. You write down in an white paper, and daily you just see that paper. Automatically, that values will go to your brain. It's like a memory-based test. You have to remember. If you want to pass, you have to remember. No other solution. I don't want to remember means you try to do all the derivation in the exam. It's waste of time. This what the conclusion. So now JK flip flop is like an what kind of flip flop? Modified SR flip
Modified
flop.
SR.
So now what are the inputs to our flip flop is, first one is J. What is the one more input to our flip flop is K. So here I am going to uh, design this flip flop. Okay. So while you are designing this flip flop, basically I am going to take my basic flip flop, which is nothing but, what are the inputs of an SR flip flop?
Progress రాసుకుంటున్నాను అక్కడ పెట్టేస్తున్నాను.
What are the inputs of a flip flop? One is yes. What is one in is yes. Next one is R. What are the outputs of a flip flop? One is Q, and
Q,
another one is called
Q
Q
bar,
Q bar. Okay.
N,
These are Q and Q bar are called as which states? Present state. What are the outputs of this flip flop? Q n plus 1. What is
N
the
plus
next output? Q n
Q,
plus
N
1
plus
bar.
1 bar.
So these are called as the next state. Okay, so already I have been shown you the diagram of sequential circuit. So combination circuit will be there, feedback. So this feedback is given by Q and Q bar. So now how to connect this? So we are having this one. Okay, so we need to find the value of S is equal to, the value of S is equal to J into Q bar you have to perform. The value of R we have to get as a K into Q. This is the conversion of an JK flip flop from SR flip flop. So what is the value of S you have to get? S I have to get it as how much? J into
J
Q bar I
into
have to get.
Q
The
bar,
value of R I have to get it as K into
K
Q.
into
So
Q.
already what is there here? Already in this block, what is there? J is there. Where is Q dash? So this is nothing but Q dash. So now how they are connected? R operation or AND operation? How they are connected? R or AND
And
operation.
up,
AND means what you have to use? You have to use an which gate? AND gate. Okay.
into Q.
So one input is J and another input is how much? Q bar. Okay. So from this you take one input and move this point to like this, and you get it connected to Q bar. Okay, so this is the connection. Okay, so from here how much we are getting? We are going to get Q bar. Okay, so now what is the output you are going to get? S is equal to J into how much? Q
Q
bar.
bar,
Next, what is the value of R? K into Q.
Q,
Already what we are
Q,
having? Already
Q,
what we are having? K is there, but
K,
it should be an AND with what? Q. Okay, if it has to be AND with Q, then what kind of gate you have to use? OR gate or AND gate?
and
We
Q.
have to use an AND
Another
gate. So this AND
Okay.
gate is connected to this point. So but here only what is there? K is there. It should be a product with what? Q value. So therefore we will take one more input, and this input we will bring like this, and already we are having q here and connect this to this q value. Okay, so when you connect this to q, it take an one wire and connect it to q value. And what are the outputs of this one? K into q. So therefore you are going to have s value, r value as j q bar and qn plus 1. So now let us try to realize our block. So shall I do for complete or shall I do only for limited? So we have
Limited.
to limitedly. Okay, very simple. Good. So now let's try to remember JK flip flop. Okay, so we are having J is equal to, let me write down the table. So J is equal to 0, K is equal to 0, and the first one. So let's try to take J equal to 0, K equal to 0, and Qn is how much? 0. Okay, so Qn is also 0. Okay, so now value of S is equal to J into Q bar and R is equal to K into Q. So what is the value of J given in the question?
0.
0. 0 into Q bar. Q bar is how much? 1. Okay, 0 into 1 is how much? 1. So what is the value of K given in the input? 0. What is the value of Q given here? 0. So 0
0.
into 0 is how much? Again 0. Okay,
0.
so when you do it, so in SR flip flop, S is 0 and R is also 0. So S is 0, R is 0. What kind of output you are going to get? 1. Okay, so now let us try to plot the JK flip flop. Okay, so when you are plotting this JK flip flop, just to see here, so J is one input and K is another input. And what is the one more input? Q, N. So how many input variables are there? How many input variables are
3
there?
variables.
Three input variables are there. 2 cube is equal to how much?
8.
8. So then how to write down the decimal numbers? You have to write down the decimal numbers varying from 0. Give the response 1,
1,
2,
2,
3,
3,
4,
4,
5,
5,
6, 7.
6,
So this
7.
table you should remember of your own. నిద్రలే పడినా కానీ టేబుల్ గుర్తుండాలి మీకు. 0, 1, 2, 3. Okay, so now 2 to the power 3 we can write down it as 8. How to write down the BCD? What is the BCD code? 4,
4,
2,
2,
1.
1. 2, 1.
Okay, so this I am keeping it aside. Okay, and I want the output where this is nothing but q n plus 1. Q n plus 1 is called as which state? Present state or next state? Next
Next
state.
state.
Now I will give a basic logic. Later on I will show you the proof. Okay, so draw the lines for every two values. So now how to write down 0 now?
0, 0,
Good. 0, 0, 0.
0,
We had
0.
written in decimal. How to write decimal 1 in BCD? 0,
0,
0,
0, 1.
1. How to write down 2 in binary? 0, 1, 0. So don't by heart. Just you see this, you can play football with this subject. How to write down 3 with this?
0,
0,
0,
1,
1,
1, 1.
1,
How to write down 4? 1,
1, 0,
0,
0,
0. How to write down 5? 1,
1, 0,
0, 1.
1.
How to write down 6? 1, 1, 0.
1, 0,
How to write down 7? 1, 1,
1,
1.
1, 1.
So here I will teach you one logic. So here the value of q n plus 1, which is nothing but next state is equal to q into n. So q n plus 1 is equal to q n means, so here the next state values are how much? Q n plus 1 is how much? See this equation. The output equation is q n plus 1 is equal to q n. What are the values of q and n? 0, 1. So you can see this is same. So this is similar to that of an which gate? SR gate. Here also you have got Qn plus 1 equal to Q as 0 and 1. So what is the output of 2 and 3? Again,
0,
0,
0.
0. What is the meaning of 0, 0? Reset. And what is the output of SR gate again here? Set, which is nothing but 1, 1. So this is called set. Here the problem is Qn plus 1. Here you are going to get it as Qn bar. I mean complementary of Qn you are going to get. Here it is how much? 0. And what is the complement of 0?
One.
1. Here what is the value? 1. What is the complement of this value?
Zero.
0. Are you able to understand? So only this is the difference when you compare an SR flip-flop with an JK flip-flop. Are you able to get it? So SR flip-flop, JK flip-flop both are same. So for 0 and 1 output is how much? Qn plus 1 is equal to Q. And after 2 and 3 what is the output? Reset. For 4 and 5 output is what? Set. For 6 and 7 output is what? Indeterminate. But this indeterminate problem is solved. We have been converted this indeterminate value into what? Qn bar is equal to Qn plus 1 is equal to Qn bar. So this you have to remember. And this is an what? This like what? What I had drawn is what? What I had drawn with green color pen is what? Table. And 0 and 1 are called as what? Truth values. Therefore, this table is called truth table of which flip-flop? What are used here? That's all. JK. And they are storing 0 and 1. They are called as which flip-flop? JK flip-flop. No one can teach you than clarity to what I am teaching. So you are blessed to have me to teach this subject. That's what I can say in one word. So if you find books also, you don't get the answers how to solve this. You have to invest a lot of time. But I want to make the things very clear. That's why I'm teaching you like this. So what is the name of this table? Truth table of which flip flop? JK flip flop. So for 0 and 1, what is the output? Qn plus 1 equal to Q1. For 2 and 3, what is the output? Reset. For 4 and 5, what is the output? Set. For 6 and 7, what is the output? Qn plus 1 is equal to Qn bar. Now we want to check it whether we are getting here or not. Okay. Now the first case, let us try to check it out. So j equal to 0, k equal to 0. Okay. So j is 0. Automatically here you are going to have 0 only. Yes or no? Small 0 into 1 is how much? 0. So k is also 0, 0. So when SR flip flop, what are the inputs of SR flip flop? 0, 0. So SR flip flop is 0, 0. What is the output? What is the output? 0. So therefore here also, here SR flip flop, whatever got 0, 0, same output you are also going to get in the form of which flip flop? JK flip flop. Now let us try to take one more input. So now take this decimal to 1. For decimal 1, how we are going to have? For decimal 1, what is the value of j? How much? J equal to 0. For decimal 1, k is how much?
One.
0. For decimal 1, what is the value of k? 0.
Zero.
And for qn, what is the value of qn you are getting? 1. Okay, now.
One.
So when you have this, I am having the inputs in terms of j, k, qn, but I don't want this. I want to compare with which flip flop? SR flip flop. What is the formula of S? S is equal to j into how much? Q bar. R is equal to how much? K into Q. Now you convert these JK values into SR flip flop. So JQ, what is the value of J? 0. What is the value of Q bar? 0. 0 into 0 is how much? 0 into 0, 0 only.
Zero.
What is the value of k? 0. And no need to write q also. Anything into q. Automatic this is also equal to 0. Now s value, r values are 0. This will be the values of jk also. Are you able to understand? S is equal to 0, r equal to 0 will be the state you will be getting for jk. So when s is equal to 0, r equal to 0, what is the state you are going to have here? 1. Okay, so therefore here we are also are going to get 1. So what is the now the answer I had got 0 1, and what is the input? 0 1. How to link these two? How to link the present state and next to qn plus 1 is equal to qn. This line is same for which flip flop? JK flip flop, and this is also similar to flip flop SR flip flop. If you understand SR flip flop, automatically decimal 0 and 1 is same for SR flip flop as well as it is same for JK flip flop. So can you do for remaining at your home?
Sir.
Yeah, I will do for last one then. Okay, so last one, j I require, and k also I require, What is the value of j value here? Let's try to do for decimal 6. In decimal 6, what is the value of j?
One.
J equal to 1. For decimal 6, what is the value of k? K equal to 1. Okay, na? So what is the value of q? Q1 is equal to 0. But I don't want the jk, all these bullshit things. I want which value? S or R value. So S is equal to how much? J into Q bar. And R is equal to K into Q. Okay, what is the value of J here? 1. What is the value of Q bar? 0. 0 bar is how much? 1. 1 into 1 is how much? 1. And what is the value of K here? Array, K, 1. What is the value of Q? 0. 1 into 0? 0. So now for an SR flip-flop, we should have 1 and 0. Okay. For SR flip-flop, what you should have? 1 and 0. We should consider and you have to write down the output. For SR flip-flop, go to SR flip-flop. 1 and 0. What is the output? For SR flip-flop, 1 and 0, what is the output? Set. Set means here also here the value you are going to get, that value is how much? 1. Okay. So now next step, let's try to do for decimal 7. For decimal 7, same is the values of j, k as well as qn. So you do this two calculation in your assignment book as a homework. Okay, na? So you try to do for decimal 2, decimal 3, decimal 4, decimal 5. You take all this and do it, and you have to get these results. So what is the value of j here? 1. What is the value of k here? 1. What is the value of q here? 1. Very good. So thank you for your cooperation. It is very hard. I can appreciate you. Why? Because no, on relaxed time also you are listening the class. I really appreciate your talent and interest towards the subject. So if you're like this, definitely you can get a job. So how to get, now I have q value, but I don't want this value. I require which values? S value and R value. How to write down S? S is equal to, give the response. You should remember, నిద్రలే పడినా కానీ గుర్తుండాలి. Like this you have to study. S is equal to J Q bar. So J into Q. What is the J value? 1. What is the Q value? No, no. See here. 1 complement. Complement is how much? 0. 1 into 0 is how much? 0. R is equal to K into Q. What is the value of K? 1. What is the value of Q? 1. 1 into 1 is how much? 1. So I am going to get the seventh state by considering S and R as 0 and 1. So come to our SR table. SR table, what is the input? We are having 0 and 1. Where is 0 and 1? So 0 and 1, if you are having, output is how much? 0. So where is that 0? Here we have 0. We have written it. Okay. So what you understand from here, I have to link present state with the past state. How I can link both? How I can link both? This is qn plus 1. This is qn. Both are not same. Both are different. So qn plus 1 is equal to q bar. This is what I'm going to get. So this table you should remember. Okay, na? So I repeat again. Please give the response of JK flip flop. For decimal 0 and 1, what you are going to get? Please respond. That's okay. For decimal 0 and 1, what is qn plus 1? Qn, super. For decimal 2 and 3, what is the output? Qn plus 1. Reset. Reset means remember all the time 0. Okay. Computer reset. Reset చేయడం all the thing you will make it as reset. So while I was taking the class, computer has been hanged. What I had done? I restarted all the program. It wasted of a time for half an hour. Now the computer will perform what? 0 0 operation. And again I started the classes. What is the output? Set. Set means everything is set now. And what is the output? 1. So if the decimal is 4 and 5, output is how much? Set. If the decimal is 6 and 7, what is the output? q n plus 1 is equal to q n bar. If you observe carefully, this jk flip flop is derived from which flip flop? SR flip flop. So 0, 1, 2, 3, 4, 5 up to this level it is same. Only this 6 and 7 has a replacement that qn plus 1 is equal to qn bar. Can you remember this of your own in the exam? So the examiner will ask you only one thing. Draw the truth table of an JK flip-flop and derive its characteristic equation, he will be asking. So whenever he asks the characteristic equation of an JK flip-flop, then you are supposed to do this derivation. Okay. So the examiner may ask you what is meant by the SR flip-flop. So draw the truth table of an SR flip-flop. He will be asking you the question. Then you should draw this SR flip-flop truth table. Can you say what is the name of this table? We are having a table and we are having zeros and one. What is the name of this table? This table is called truth table. So it are zeros and one are there. Therefore, this is called truth table of which flip-flop? Yes, or flip-flop. Okay na. So and here with this decimal and one more input we are giving, I had already told if the flip flop has to function, what has to be given as input? Clock pulse. So we here we have to give the one more input which is nothing but a clock pulse. So this is clock pulses. If you give the clock pulse only, they will work. Now we have learned 90% of our syllabus. Now everyone will do this, remember this table, but the examiner will not ask sometimes the truth table. He will ask you, give me the characteristic equation of jk flip flop. Now again, now let's try to do the second step. I think up to here you are confident, yes or no? Yeah, super. Thank you. Now we want to derive the output equation, where this output equation is called which equation? Characteristic. This is called an characteristic equation of a JK flip flop. I think had you written the notes? Okay, good, super. Now let us try to do this characteristic equation. So in order to draw this characteristic equation, I can get this characteristic equation by using a map, where this map is called as which map? K map. Where K is called as which map? Kernel map. So how many variables are there at input side? 1, 2, 3. So then we will try to draw a box. Okay. So like this you have to draw one box. Okay, how many variables are there? Two variables. Write down the jk in this box. And after this, what is the one more variable we have here? Qn. This is also an one more variable. So one, this is one variable. How many possibilities are there in one variable? Either it will be 0 or it will be 1. So now after drawing 0 and 1, you draw one line. You draw one straight line. Okay, so we segmented into two boxes. So how many possibilities we have to plot it here? How many possibilities? 1, 2, 3, 4. So up to how many possibilities? 8 possibilities. Whatever is there in this table, you should keep in this K map. Then I have to divide into boxes. So this is 2 next, 4 next, 8. Yes or no? 1, 2, 3, 4, 5, 6, 7, 8. So now how to match this value is we have an logic. Okay. So here we will write down it as 0, 0. Okay. Now, so here you are going to write down it as 0, 1. So just remember the code 4, 2, 1. So first you will write down 0, 0 means how much? 0. 0, 1 means how much? 1. Next you will write down 1, 1. This is nothing but a logic in K map. So you have to write down in the sequence 0, 1, 2 as well as 3. This is the formula of K map. So how to write down 0 in the form of 2, 1, 0, 0. How to write down 1, 0, 1. How to write down 3? How to write down 3? 1, 1. How to write down 2? 1, 0. Now you see here the possibilities. All zeros. 0, 0, 0, 1. How much? I will say the binary number, you say the decimal number. 3 zeros. 0. 0, 0, 1. 1. 0, 1, 1. 0, 1, 0. 100,
4,
101,
5, 5,
111, all ones, 7,
7,
110, 6. Yes or no? So in
yes,
this
sir.
table, whatever is there here, we completed into this table. But remember, first digit should be 0, and second digit should be 1, third digit should be 3, and next digit should be 2. Sir, why you have to write down like this? This was developed by a scientist called as kernel. So this is a very good intelligent person. That's why this map is called kernel map. He designed this technique of simplification of this equation in computer. So you can see your computers also kernel memory. This called kernel K map. Okay. So now we can see here. So now you say me the combination. So all zeros are there. You see these triple zeros are there. What is the output? Everyone see here. So the output of this we are going to get the equation is which is qn plus 1. So three zeros are there. So this zero, row wise zero, column wise zero also. All zeros are there. What is the output?
0,
0. Now 001. 001. What is the output?
1,
1. Next 011. 0. Just see here. 011. What is the output?
0,
0. Next, what is the
3,
output? 010. 010. What is the output?
0,
0.
0,
Next, 100. 100. What is the output?
1,
1.
1,
Next, 101. 101. What is the output? 1.
1,
Next, 110. 110. What is the output? See this
0,
110. Where you are going to have?
1,
Here.
1,
Next,
1,
all ones.
0,
0. So we plotted this qn plus 1 8 digits in a map where this technique is developed by a scientist called kernel. This map is called kernel map. So now we have to identify the twos, I mean ones. How many ones are there? One, two, three, four.
4,
We should circle even number of ones. So here two ones are there. I can make a circle like this. Yes or no? I
yes,
made one
sir.
round
Yes,
of
sir.
1 1. So these two ones has been eliminated from the program. But how many ones are there again? Two ones are there. Okay. So how to make the map is either 1 1 should be in same line, or 1 1 should be in diagonal, or 1 1 should be like an cyclic. Are you able to understand? How to making the map is both should be in a row, both should be in side by side, or both should be in column wise, or four values should be in same place, then you can make it as a circle. But here this 1 1 we made one group, so this group completed eliminated. But this one is there, here one is there, then how to match? So therefore we can draw one arrow mark like this and this will get matched. Are you able to understand? These two will get
Okay.
matched. So therefore you are going to get the equation of q n plus 1. Let's try to do it here. So here we had taken one element as qn. Q, what is the how to write down one? Actually there's no value for one, but you have to write down in terms of equation. So j, k, q, n are inputs, but I want output in terms of what? Input variables. So this 0 and 1 I have to write down in terms of input variable. How to write down 1 I can write down as please respond qn. How to
Q,
respond 0?
N,
Bar. Super. So here zeros are there. How to write? For example, let's try to write down here. 1 1 is there. How to write down jk? J means 1, k means 1.
1,
So how to write down 0 0? If
J,
1 is there, we'll write down j. If 1 is there, you'll write down k. 1 is there means you just write down the value. 0 is means you put an bar on that. So 0 0 is there. How to write down? J bar. Very good. K bar.
K,
Now how to write down this 0? First digit is what? J. How to write down? J bar.
K,
Super.
K,
Simply super. How to write down this value?
K bar,
Super. Simply super. So now first we separated this 1 1. For this I will write down. So this 1 1 is there. So one is q bar, another one is q bar. Any common term is there here? No. One is 0, one is 1. So there is no common term. We cannot write down. But only one term is left. What is the name of this term? So this is nothing but
J bar,
j bar k is one term. Okay. So qn plus 1 is j bar k plus. So this pair has been completed. Now coming to this pair. So this pair is there. at this level and this pair is there at this level. These two ones you have to write down the equation. So these ones are there in second row. So what is the value of second row?
Q.
Qn. So first write down the value of Qn. And these ones are there in first column as well as they are in fourth column. So in this column, you should not write down the common term. You should write down only common term. So here 0, 1 is there. Here 1, 0 is. What is the common term? 0, 0 is there.
K
Here
bar.
1, 0 is there. What is the common term? 0 is the
K bar.
common term. Therefore, where we can write down this value as how much? K bar. Okay. So therefore, this one is for this equation and for this is the equation. So hope you understood this K bar. Shall I teach again?
Master.
Not required. Good. So 1 we can write down as Q1, 0 you can write down as Qn bar. So J and K will write down as JK. So I will say the mapping, at least you can understand. If you map it, map. Okay. So if you make map, is there any common term in 0 and 1? No common term. Therefore, we cannot write down. But this is only one term is common. That way, therefore, we are written as J bar into K. So this pair is completed. So 1 pair. So this is in one corner, this is in another corner. So all these are common to which one? Common to which one? Qn. So Qn is in
Q.
second column, but this is in first column, this is in fourth column. In first column and fourth column, what is the common element? Common element is what?
K bar.
0, 0.
K
So
bar.
0 can be written as how much? K bar. That's why I multiplied with the K bar. Now, what is the characteristic equation of an JK flip flop? Is very simple. J bar K. So J bar
Plus
K plus Qn K bar.
Q1 K bar.
So this is what you have to get. So now you try to write down. Right, this is the end of the dangerous subject, the JK flip flop, and we have the last concept, which is nothing but the toggle flip flop,
D flip flop.
D flip flop. So with this is the end. You no need to attend any other online classes. Everything is closed. So than this, no examiner will ask you any question. So just everyone write this excitation table. Okay, is it completed?
Sir.
Okay, shall I proceed?
Yes, sir.
Okay, good. All the time I have to check whether you people are active or sleeping. Rather than class, no, this is my work. Ramya, completed derivation.
Yes, sir.
Okay, good, super. Nani,
Yes, sir.
okay. Gayatri, sleeping in hostel. Huh? Gayatri, not there in meeting. Super. Monica,
Yes,
Mon.
sir.
Okay, good. Okay, good. You're active. Total 60 strength. No, only 20 students are interested to pass the engineering. That is what your analysis is. In 20, 60 students, only 20 want to pass. That's why the strength is too less. Okay, anyhow, it's your headache. How you take. So hope those who are listening the class, are you confident? Can you write the truth table in the exam?
Yes, sir. Yes, sir.
Super, good, super. Go ahead. You please explain the same thing to your friends also. Those who are absent, at least by you, they may pass. So now let us try to go with the next flip flop, T flip flop. So this is the end of flip flops, and this is the end of our syllabus. And in the class, we will revise this and we will go with the counters also. Okay. So T flip flop. So what is meant by an T flip flop means so is the pen visible to you?
Yes, sir. Yes, sir.
Okay. T flip flop means it is called as a toggle flip flop. Toggle, toggle flip flop. So toggle flip flop means what is meant by toggle means opposite. If you have anything in opposite in nature, then when you have anything in complementary in nature, then it is called a toggle flip flop or it is called T flip flop in shortcut. So a T flip flop is also called as expanded as toggle flip flop. So we are going to get this T flip flop from an modified JK flip flop. Okay, when you modify this JK flip flop, we are going to get this T flip flop. Now, what to modify and how to modify. So now let us try to take uh, JK flip flop. This is J flip flop. K. So inside JK flip flop, can anyone see which flip flop is there?
Yes, sir. Start
Super.
flip flop.
What are the output of this JK flip flop? Q and Q bar.
Q. Yeah.
So in JK flip flop, SR flip flop is there. In JK flip flop, we are going to have T flip flop. So we will take T directly connected. This is a toggle is directly connected to J, and the same T we are going to connect to K. Okay, same T is connected to J and T is also connected to K. But when this flip flop has to work, we will give an signal. This is called as a CP. So what is meant by CP means CP is nothing but a clock pulse. CP is nothing but clock pulse. Whenever this T flip flop has to work means you have to give the input as 0 and we have to give the output as 0 and again 1 0. So these signals are called clock pulse. If you give this clock pulse to this flip flops only, they will work. If you don't give it, automatically they will off. So at this point 1 only they will be on, another point they will be off. Now how to get this output? Now check it, the table how to draw this. Okay, so how many inputs are you having is one is T, another one is Q. Now let's try to draw the truth table for this flip flop. So T is there, first input is T, another input is Qn. Okay, how many inputs are there?
Two in.
Two
Two
inputs.
inputs.
How many possibilities we can write down? Two squares are. Two
Four.
square means
Four.
4. So 4 we are going to get means we have to write down the decimal value. How to write down 4 decimal values? 0, 1,
Zero.
2,
One.
3.
Two. Three.
I'm continuously saying is that this is a flip flop. If the flip flop has to work, what I have to give? Clock pulse. We have to give. This is the symbol of an clock pulse. Clock pulse is given at 0. Clock pulse is given at 1. Clock pulse is given at 2. Clock pulse is given at 3. Now you have to get the values of T as well as Q. So T and Q are called as input and output is how much? Q n plus 1. How to write? I mean, how to write down this in binary form? This is 2, this is 1. So say the binary equivalent of this value 0. How to write down? 0, 0. How to write down 1? 0, 1. How to write down 1? 1, 0. How to write down 3? 1, 1. So this after drawing, you have to draw one line. Okay. So here this is state q n plus 1 is equal to qn. Okay. And another state q n plus 1 is equal to qn bar. Okay now. So now what is qn value? Qn is how much? Qn plus 1 is how much? Qn. What is the value of qn here? 0. Automatically what you are going to get here? 0. This is 1. What you are going to get here? 1. Here it is 1. How much you are going to get here? So Qn plus 1 is equal to whatever the Qn is there, same Qn will get in Qn. But in Qn plus the next state, we are going to get complement. So complement means here 0 is there. What are you going to get? 1. Here 1 is there. What are you going to get? 0. So the here we don't have four states like that. 0 to 7, you have only four states. And first decimal 0 and 1, you are going to have the equation Qn plus 1 equal to Qn, and another state you are going to have Qn plus 1 is equal to Qn bar. So for this table, what is the name of this table? This is like an table. Therefore, this is called as an table. And here in this table, what is there? 0 and 1 is there. Therefore, this table is called truth table of what we are doing. T flip flop. T means toggle flip flop. Why it is called toggle? Output is Qn and another output is Qn bar. So therefore it is an both Q and Qn bar are which nature? Opposite in nature. This opposite in nature technically is called toggle. So whenever these are opposite in nature, these are also called complementary. Both the outputs are complementary. So both the outputs are complementary in nature means this is going to have two stable states. How many stable states are there? This is one stable state. This is another stable state. Here it is going to have two stable states. If two stable states are there, this is called as flip flop. A flip flop all the time should have two stable states, then it is only called flip flop. Okay, so this is how we had got the truth table of an T flip flop. Now, from this truth table of this T flip flop, what we have to derive? We have to derive the output equation. Okay, so we have to derive the output equation. So, what is this output equation? What is the name of this output equation? Already we discussed. What is the name of this output equation? Characteristic equation of which flip flop? T flip flop. Super. How to get the characteristic flip flop? Characteristic equation of a T flip flop. We have to use a technique which is called as K map. What is K map? Kernel map. So how many inputs are there? Two inputs are there. So now we will take the inputs like this. So I will take the K map. So what is the first input I am taking is T. Another input I am taking it as Qn. So in a Qn, how many inputs are possible? One is 0, another one is 1. So try to draw one line. In T also, one variable is there. In one variable, how many possibilities are there? 2 to the power 1. 2 to the power 1 means how many possibilities are there? Two possibilities. How to write down? 0 as well as 1. Draw one line. Okay, just to combine this. This called K map. So now how to write down 0? How to write down 1? How to write down 1? Qn. How to write down 0? Qn bar. How to write down 1? T. How to write down 0? T bar. Okay now. So now you see here what is the combination 0 0. Okay, so here you are going to have 0 0 combination. Here you are going to have 0 1 combination. Here you are going to have 1 0 combination. Here you are going to have 1 1 combination. So if 0 0 combination, so T0 Q0, what is the output? 0. If T0, if T0 Q1, how much? 1. If Q is 1 and T is 0, 1 0 combination, what is the output? 1. 1 1 combination, 1 1 combination, what is the output? 0. So now we implemented all these truth values into our K map. So now what we have to see? We have to round even number of ones. Is the ones are there? We cannot map. So this is in this side and this is in. So can we map upper side also? So these are not needed. I already told if you want to map, they should be in row wise or they should be in column wise, or one should be at one end or one should be at another end. It may be in same row or it may be at same column. Is these three possibilities are there here? No, we can't do anything, but we can do directly how to take this element. So for this element 1, what is the row value of this row? What is the value of this row? Q n bar. And what is the column of this value? T. Okay na? So for this one, how to write down? What is the row? Qn. What is the column? T bar. So therefore, the output characteristic equation Qn plus 1 is equal to Qn T bar plus Qn bar T. So you can see here Q and T are Q and N are Q and T are toggle in nature. Therefore, this flip flop is called toggle flip flop. So this is called the output equation or the characteristic equation of an which flip flop? T flip flop. Very, very, very important. The examiner will ask, draw the truth table of an T flip flop. If you want to ask more, draw the characteristic equation of an T flip flop. For you, I am openly saying, till now this syllabus is not completed to any of the students in the complete college. Only for you this is completed. Definitely you will get these questions in your end exam. So please be prepared to explain to the remaining friends and students. Okay, so can you write down? Shall I revise or you are able to understand? Okay, how many flip flops you studied today? First one is SR flip flop. This is SR flip flop. D flip flop means delay flip flop. We will connect directly to wire S and we will connect one inverter to R. then you are going to get the characteristic equation. JK flip-flop means is a modified form of SR flip-flop. Therefore, you are going to
Yes,
get the
thank you.
JK flip-flop. S value is equal to J into Q bar.
Yes,
R is
yes,
equal to K into Q. Best. So already I had done it for only for which values? I had done it for 0 and 1. Here I had done it for 0 and 1. So you should practice for what? You practice it and show me in the classroom for 2, 3, 4, 5. You take j equal to 1, k equal to 1, qn equal to 0, and see that you convert this jk into SR flip flop and see that whatever the SR values are there, you just write down whether you are getting correctly or not. So after this SR flip flop, what we discussed? T flip flop. So uh, so this is all about T flip-flop. So this is the characteristic equation of an T flip-flop, which is Qn into T bar, Qn bar into T. What is the characteristic equation of an JK flip-flop? J bar, I mean J into
yes,
Qn bar plus K bar
yes,
into Qn.
yes,
And what is the characteristic equation of a D flip-flop? Qn plus 1 is equal to D. What is the characteristic equation of an SR flip-flop? You should remember all these four, write down in a box.
yes,
So what is the characteristic equation in SR flip-flop? S plus R bar into Qn. So this is the end of the syllabus. We have the registers we will discuss in the class. So thank you everyone and individual for listening the class patiently. Thank you
thank
and very happy to see you here. So thank you everyone for listening the class patiently and getting lot of knowledge to make you to crack this exam. So thank you all. Thank you for coming to the meeting and thank you for patiently sacrificing your sleep, and thank you for listening. So those who had missed this class, I will try to keep it in the what is that live. So you can go to the channel and you can see these videos in the live also, and you can practice of your own. Okay. So thank you all. Thank you for your time. So
you,
have a
sir.
great day. Have a happy
Thank you,
weekend.
sir.
We will meet in class. Okay. So remember, you have exam on Tuesday, and these four flip flops you write down as an assignment question also. Flip flops, characteristic equation, as well as the truth table. Okay. So write this new question. Okay.
Yes,
So thank you all. We will meet in the class. So we can
thank you.
exit from the
Hello.
meeting happily. You can relax.
Hello.
Okay. Any doubt you can ask. So thank you. You can end the meeting.